Hi, my name is Jan Czech and I work as the project manager at EGD.
My name is Eugenio and I work at E.ON Group Innovation. I'm the technical product owner and developer for HIVE.
I'm Robert Pínčka. I'm from the Czech Technical University in Prague, from the Multi-Robot Systems group.
The goal is to help improve how we manage and maintain the electricity grid. Maintaining the grid is essential for reliability and the safety. Our infrastructure spans up to the thousands of kilometers in the rural and also in the urban areas. Currently, we are doing the inspection by walking, so it means that our field technicians are just visually checking the overhead lines if there is everything all right. And the second type of the inspection is the climbing. So our technicians are climbing on the tower, but it is done just every 4 years. So it means that there is a lack of inspection meanwhile. So the drones can help us to inspect in higher resolution the isolators, and also it can be more efficient than our current inspections. The benefits of the drones are it is safe, it is efficient, and it provides a structured data.
Drones, and particularly the multicopters, the ones that are small, are perfect for this task, but they suffer a lot from limitation of the range and the limitation of the battery. So how long can you really fly without having your battery drained? That's the question of efficiency, and this is what we're trying to solve. HIVE is a technology that enables highly efficient drone operations when there are very large critical infrastructure. It's a software that enables the operators to coordinate and supervise missions where multiple drones are used to collect data in real time and in parallel way. So it's all about efficiency. On one end, you have a mission or flight that you want to run, and if you have a drone, it will be taking some time, but then you take this task and you split amongst different drones, and they will take less time to finish and complete the flights altogether, and then therefore you can extend the reach and the range of the operations.
I would say the uniqueness of the system is in the autonomy of the operations, because we can plan the inspection missions really like by clicking some button, and it will plan the entire mission for 2, 3, 4 drones even, and then the operator can run like all the drones at the same time, not really involving that many humans in the loop, and we can scan really long power lines at the same time as would otherwise involve many people.
We don't have one person anymore supervising only one drone, but one person that supervises a fleet of automated drones. And while they're flying up in the air, this person doesn't have to wait until the drones are back, but rather pick them up somewhere further away in the direction of the power line, for example, or the infrastructure. Typically, it takes around 1 hour to inspect 8 to 10 pylons of this type here. So clearly depends on the number of waypoints and the distance between the pylons in the power line, but we can say that on average 8 to 10 pylons is what you achieve in 1 hour of work. And now with HIVE, we demonstrated twice that it's possible to reach a speed of 20 to 25 pylons per hour. And that's an efficiency gain of 100 to 150%.
Automatic drones needs input data for creation of the flight route, and this is done by the 3D model of the overhead lines, which is called LiDAR data. And these LiDAR data are captured by the drones or by the helicopters. So it means that you need qualified personnel to capture this data, also analyze them and work with them. So it is quite expensive. In EGD, we have about tens of thousands of overhead lines, so it means that we would need a large investment to capture all of this LiDAR data at once.
We want to achieve efficiency also in different ways. With the same approach, you can also think of the drones as taking different types of tasks. So imagine every drone has a specific role. One drone is dedicated to take the pictures, for example, and another drone is flying while taking the point cloud data. So you have the possibility of combining different applications doing the same flight.
We did what we call mapless flight, where we do both end-to-end the scanning of the power line or of the pylons, and then we create the plans online and then we do the inspection immediately after that. So we don't need any map before to, for example, to run some mission that collects the point clouds, but we run everything end to end.
And that's the reason why HIVE makes sense, because we can, during one mission, capture the LiDAR data and also perform the inspection itself.
So I love the collaboration because everyone is really deeply involved and pushing their small task, and in the end we integrated everything and everything worked.
The key moment for us was to really work closer to EGD in this case, one of our core partners in this project, where we wanted to understand better how drone operations was done in the field today to really get closer to the business need.
To be honest, it is the learnings, because working with Eugenio is not just the development of something new, but it is also about thinking out of the box, because this is nowhere else. Nobody is doing that. It is so unique.
While I believe that the future of inspection will be fully autonomous, and the drones will cover the whole grid, I think with HIVE we're really taking the right step towards that future. And we're working hard, and we really believe that it's highly possible to bring step by step our approach into the real world and then play into the vision of the fully autonomous inspection system of our grids.